Hello, dear Psychonomic listeners. My name is Eda Mizra. I'm going to talk about the work we did with Klaus Oberauer at the University of Zurich today. This one is about time. In this talk, we are going to explore what is time good for in working memory. We have plenty of research on the possible effects of time on working memory. These research mostly focus on how working memory representations might decay with the passage of time. But also, there's research showing that time to process information in working memory, such as presentation rates or the time given after a study list item, improves memory. So today we will look at the specific and beneficial effect of time on working memory, which is the unfilled time that is given in between study list items during encoding, improving performance. So imagine we have a list of 7 letters to study and are asked to immediately remember them, such as we do in a serial recall task. One is presented at a fast pace and with 100 milliseconds in between items, the upper one, and the other one is presented at a slow pace with 1000 milliseconds between items. What we observe is better performance for lists that were presented at a slow pace, which means that increased inter-item time seems to enhance working memory performance, and we are interested in this beneficial effect. Mainly, what we want to know is what is happening during this time that improves working memory performance. So there are two aspects we can look at the effect of time. On the left side, we can say there is more time for instance, maintenance mechanisms that in which we work on the just presented items, like we can rehearse them, refresh them, or elaborate on them. And there is more time to consolidate the items that we had just seen. So we try to strengthen the memory trace of the just presented items. But with more time, what can happen is that like the items also can become temporally distinct. So there might be an increase in temporal distinctiveness, which would also have an effect in general in working memory performance. Additionally, the temporal context shifts. So it will shift with increased time. That means that the studied items will be less similar to each other in the temporal dimension with more time. In the first experiment, the first question that we ask is whether the free time benefit is local or global. To do so, we varied the durations of inter-item time within the list. So participants studied 7 consonants in a study list, as this one, and were asked to remember them in the order that they had seen. Inter-item times were either consistently short across the list, such as this one, or consistently long, such as this one, or they were varied within a list, different for all positions, but the average inter-item time was as long as in the consistently long fixed ISI condition, the orange and the blue. And here we had from 50 milliseconds to 2000 milliseconds, different ISI durations, and they could be in any position in the list. The aim of the variable interval condition was to test whether the duration of each inter-item time has an effect predominantly on the adjacent items, that would be local effects, or spread across the list items, that would be global effects. For instance, let's look at P on long fixed and long variable condition. P has longer post-item time in the long variable ISI condition, and we will look whether this long post-item time has an effect on remembering P. If the effect is local, we should see that P is better recalled as a function of post-item time. The same could happen with pre-item time. In that case, B would be remembered better because it had a longer pre-item time. But if you don't see specific effects on the items as a function of pre or post-item time, that will mean the effect is global. I'll jump into the results now. We will first look at the serial recall accuracy as a function of serial position in the list and the 3 conditions. So what we see here is that both long fixed and long variable conditions, orange and blue lines, have better performance compared to the short fixed manipulation. This tells us 2 things. Longer inter-item time helps, which we knew already, but it also helps when it's variable and unpredictable, not only when it's fixed and predictable. And as you can see, the long variable and long fixed conditions didn't differ in performance. So second, what we looked at is that performance as a function of pre-item time and post-item time. This is important for the long variable condition, of course. And what we're trying to see is that if pre or post-item time had local effects, then we would see as this time increases, then performance should also increase. But we found no effect of pre-item or post-item time duration on performance. Findings from experiment 1 suggest that free inter-item time has global effects that spread across the list and is not reflected on just local items. Another question we had was whether the inter-item time benefits the items before this time or the items after that time. So is the benefit proactive or retroactive or both? So in this experiment, we will test which items benefits from a long inter-item time. Instead of varying the inter-item interval for all list items together, we varied the duration of only one of them. So we gave one long ISI and the rest was short, as in the short fixed condition, and location of this ISI was shifted across the list. In order to see if this gap between the study list items created temporal grouping effects, and to control for them, we also included a short gap condition that also had a gap but was shorter than the long gap condition. So we wanted to measure the free time benefit on top of temporal grouping effects. So in this experiment, we had three conditions: short fixed condition, a long gap condition, and a short gap condition. And we're interested in the differences between the long gap and the short gap condition, because both of these conditions will have temporal grouping effects, but on top of the temporal grouping effect, the long gap condition should have the free item time benefit. In all conditions, participants studied a 7-consonant list and were tested immediately after encoding with a serial recall task. The aim of experiment 2 was to test whether the free time benefit is proactive, retroactive, or both. Additionally, free time benefit, as in experiment 1, could be local or global. To test these, we will focus on the effect of free time as a function of the lag between the gap and the presented items. So we will look at the short and the longer gap conditions. If KLS in the long gap condition had better performance, that would mean a retroactive benefit. If PBDF is better in the longer gap condition, that would be a proactive benefit. If specifically P and S is better in the longer gap condition, that will be a local benefit. If all the items from the longer gap benefited from this, it will be a global benefit. So we will calculate the lag between the gap and the items around it. And by doing so, we can analyze the impact of free time on preceding and subsequent items separately. So the lag is calculated as the signed distance of the items from the inserted gap. For instance, if the gap was between third and fourth item in the list, the third item would be at lag -1, and the fourth item would be at lag +1. We will exclude to position 1 and 7 from this analysis, so accordingly, we will have 10 possible lags from -5 to +5. Negative lags include items preceding the gap and will be used to test retroactive effects. Positive lags include items subsequent to the gap and will be used to test proactive effects. So first we did a temporal grouping check. Temporal grouping effects should be present for both short and the long gap conditions. So when we introduce the extra temporal gap somewhere in a list, it causes temporal grouping. That is, people break the list into two groups at the point of the gap, and that is known to improve memory. However, we are interested in the effect of free time on top of this effect. So we wanted to make sure that both long and short gap conditions had this temporal grouping effect. One of the observed effects of temporal grouping is a sharp increase in the response times to the item following the gap. So we will look at the gap +1 item response times for both conditions, like all conditions actually, to see whether there was temporal grouping. And what we see is that here, no gap condition had lower response times compared to the gap +1 item in long and short gap condition. And we also looked at the other items, not just the ones following the gap, but all the other items. And in that one, we don't see any differences. So when we looked at the gap +1, only for that the item long and short gap conditions had higher response times. That assured us that temporal grouping happened for both conditions. Here I'll show you what time helps and what it does not. So we'll see if it has a proactive or retroactive effect or both, or if it is a benefit, if it's a local or global benefit. So on the y-axis, we have serial recall accuracy. We'll look at the long and short gap conditions, long in orange and short gap in blue lines. And we will look at this performance as a function of the lag. So the minus lags will show us whether the effect is retroactive or not. And the plus legs will show us whether the effect is proactive or not. Um, so let's look at it. We had two experiments, by the way, here. The first one is experiment 2, as I just showed, and the second one was the replication of it. So let's look at the left one first. What we see is that there is a notable difference in proactive memory, where performance was better for the items following the long free time compared to the items following a short free time. And what we also see is that there is no difference between long and short free time in retroactive memory performance. In other words, performance of the preceding items was the same for both long and short free time. So we also see that the proactive effect is basically across all the positive lags. So it's not just a plus one. It is not a local effect. It seems to be a global effect. We then asked which of the existing accounts predict a proactive and global benefit. Firstly, maintenance mechanisms such as cumulative articulatory rehearsal, cumulative refreshing, or elaboration of sets of items predict that time should benefit preceding items, so a retroactive effect, and because they are cumulative, it should have a global effect. And for instance, elaboration of single items would predict a retroactive and local effect. Second, short-term consolidation predicts a retroactive benefit. The free time is used for consolidating the item preceding to the time. And according to some theorists, consolidation is a ballistic process that cannot be interrupted. So when the next item is presented, while the previous item is still being consolidated, it is the following item that suffers. And with more time, this item would benefit from this as well. So a retroactive and proactive local benefit. With extended time gap, two parts of the list get separated from each other contextually. This should improve both sides of the gap. So the temporal context shift between the preceding and subsequent items could improve both sides, leading to both retroactive and proactive benefits. And finally, temporal distinctiveness account predicts local effects, just effects around the temporal gaps. So in summary, none of these accounts predicted the effects we observed. To go back to the question of what free time is good for in working memory, what we can say is that extra time we gave to participants had a local and proactive benefit. And we were unable to explain this effect by the existing accounts in their current form. There are two possibilities that can explain our results that we thought of. The first one is that maybe participants use this time to chunk the preceding items I'm talking about experiment 2 here. And chunks would take less space in working memory, which would free up working memory for subsequent items. But surprisingly, the memory for the preceding items, the chunks didn't change. And this is not an observed effect in the literature. When you chunk the items, the memory for the chunks are also better. So we are not sure about this at the moment. Another possibility that we thought of is that a novel account that suggests there is a limited encoding resource which depletes with each item and it recovers with time. This account is the only account that predicts a proactive benefit for the results we have. This is because with the longer gap, participants will have more time to recover encoding resources, and that would only benefit the subsequent items, not the preceding items. However, this is a new account and had not been applied to many working memory tasks yet, or the serial recall tasks. So we are currently testing whether it predicts the data pattern we observe in this study and other studies in which inter-item time is manipulated. But what we can say is that the time benefit is proactive and global. And this work calls for a new way of thinking about the role of time in working memory. Thanks for tuning in, Psychonomics. I hope you enjoyed it.